This program is rated GE. Content carried in here is suitable for general family viewing.
To children in class 6, 7, and 8, and even any other person who is interested in maths beyond, because I believe it goes, our syllabus is spiral, that whatever is learned in class 8 will be taken from 1, and it only gets more complicated. So today I want us to take you through the intervals and revolutions. It is under measurement. I want to start by giving you, one day I went to class, I wanted to teach measurements. So the moment I entered the class and I wrote measurements on the board, then the children jumped up. Teacher, Kenya has dug many dams containing maji. Then, what is this? I've not come here to teach you social studies. I've come here to teach you maths. What are you telling me about Kenya has dug many dams containing? It took me like 1 minute to understand them. Then I told them, okay, can somebody tell me what you are telling me about this Kenya has dug many dams containing minerals? Some were telling me Kenya has dug many dams containing minerals. Another group, Kenya has dug many dams containing maji. Told one boy, Njuguna, tell me what you are talking about. Then Njuguna stood up and told me, teacher, whatever you want to teach us, I think we did it some time back. So the syllabus is spiral, and what they were trying to explain to me, that Kenya has dug many dams containing minerals. Dear Lana, you can see that this thing is not related to maths in any way. But they told me that it is a way in which we know the units. So the first thing that a child, a learner, should know is always the conversion of the units when we want to deal with measurements. So this K, they told me that this K stands for kilometers, that this H stands for hectometers, that this one stands for decameter, this one stands for meter, this one stands for decimeter, then this one stands for centimeters. Then we have the millimeters here. Then I told them, thank you very much. I've learned something from you, because learning never stops. We stop learning when we die. So this one will not be part of what we shall be learning today, but this one will be very, very instrumental for us. When we are converting units from one sum to the other, we shall need to know that 1 kilometer, how do we convert centimeters to kilometers? So they told me that you just write 0 from wherever you are. Just write 0, 1, 0. So I'll rub these parts of Kenya. They told me, teacher, just write 1 0. Then the next one write 2 zeros. The next one write 3 zeros. The next one write 4 zeros. The next one write 5 zeros. The next one write 6 zeros. So how was this one helpful? This one means that when we want to take like centimeters to kilometers, we shall find that 1 kilometer is equal to 100,000 centimeters. I think these were very clever learners. But I always tell children that in maths, you don't need to cram. Maths, you need to know. You just need to know, then you'll be good to go. You don't need to cram anything. You need to know what you want to do. And maths falls, there are 3 basic concepts that you need to know when dealing with maths. We have to be fast. Maths is all about speed. Maths is about accuracy. Maths is about it's about the formulae. Some people call it formulae. It's formulae. Maths is about speed, accuracy, and formulae. So today we want to look at intervals and revolutions, and we shall start with intervals. We shall start with intervals. We shall start with the intervals. I always like explaining terms. Before I introduce a topic, I want to explain that what are these intervals? What am I talking about? Under this one, we shall get what we have: distance, and we shall also find what we call the number of posts. There is this question that is always very common, that somebody wanted to fence a place. Somebody wanted to fence his farm using certain number of posts. Or we can fence using posts, we can also fence using flowers. He wanted to fence his piece of land along a straight line or in an enclosed place. And he was using posts placed at different distances. So the length between one distance to another is what we call interval. Let me explain it in simple terms. Like if we have point A to point B, say that Mary wanted to fence this piece of land. She wanted to put posts along this line. So maybe they were to be put at 5 meters apart. So the length from here to here, this is what we call the interval. That is what we call the interval. So that takes us to our very first subtopic in this subtopic. We want to look at how to get number of posts that can be used when teaching about an enclosed area. When somebody wants to fence enclosed area, when you want to fence an enclosed area, let me give it Roman 1. Like an enclosed area is an area that is totally sealed, like this one. This is a triangular shape. Maybe you want to fence this piece of land, and you are using certain number of posts. The question that can come in such an area is that Mary wanted to fence this piece of land using a certain number of posts. How many posts was she going to use? To get the number of posts used here, so we shall write number of posts. The number of posts or flowers used to fence this one will be, we get the total distance. We take the total distance. We divide with the intervals. We divide with the intervals. An example in a question would be, let me give an example in a question, that Paul intended to fence his rectangular piece of land measuring 120 meters wide, long 60 meters wide, using posts at intervals of 5 meters. How many posts did he need? How many posts did he need? Paul intended to fence his rectangular piece of land measuring 120 meters long, 60 meters wide, using posts at intervals of 5 meters. How many posts did he need? So what you need, maths, you always need to interpret the figures remove the figures now, take them to now real work. We need to know what is the shape of a rectangle. That it was 120 meters long and 60 meters wide. And the posts were placed at intervals of 5 meters apart. So how many posts did he need? To get the number of posts needed here, we have to work out the total distance around that figure. And finding the total distance around this figure would be finding the perimeter. Perimeter is the distance around an object. So we shall first find the perimeter. And we know that this is a rectangle. Perimeter of a rectangle is equal to 2 into length plus width. 2 into L plus W. So we shall take 2 to length is 120 plus width is 60. We add this to this, we get 180. We take 2 times 180. We know that one is 360. 360 meters. So that is the distance around that figure. But that is not the question asked. The question asked here is how many posts did he need to fence this piece of land? How many posts did he need to fence the piece of land? So we shall come back to our formula. We say that the number of posts in an enclosed field is equal to the total distance round. We divide by the intervals. The intervals we are given here is 5 meters. So we shall take, we apply the formula, 360 divided by 5. That is simple division. We don't need to do much cancelling there. You know that 5 goes into 36 7 times. 7 times remainder 1, there are 2. So we shall have 72 posts. And you are good to go. You've gotten your marks there. We move to the next subtopic in that place. And having dealt with the closed area, we are now going to work out. We are now going to find number of posts that are used in a region that is not enclosed. In a region that is not enclosed. In a region that is not enclosed. So, let's give it B. I'll call it non-enclosed region. A region that is not enclosed. Like, we want to get the number of posts that are used when you are given a distance like this. This is what I mean, not enclosed. A straight line. And to get the number of posts used in a straight line, we shall simply divide the intervals. We say that the number of posts used here will be the total distance. We divide with the intervals. Then we add to 1. We add 1 to it. If we want to get the number of poles used here, or even if they were flowers and they are placed this way, to get the number of posts that are used, we take the total distance, then we add to 1. Why do we add 1? We add 1 because there will be the last pole that will be placed here, and it will not cut off for any distance from there. So that is why we add 1 here. We add 1 because there's that last pole that will be put at the end, and it doesn't cut off for any distance. An example in a question would be, so this will be our example too. The length of a road leading to a chief's camp is 1.8 kilometers. Trees were planted along both sides of the road. Trees were planted along both sides of the road. If the trees were planted, if the trees were 20 meters apart, how many trees were planted? How many trees were planted all together? How many trees were planted all together? How many trees were planted all together? The length of a road, always have a clear picture in the mind of what you want to do. Translate the sentence now to the practical work. We know that a road is a straight thing. It is not an enclosed region. That the length of a road leading to the chief's camp is 1.8 kilometers. These ones are not necessary. There is no way you are going to draw the chief's camp. You just need to draw a sketch of the road. And we are told that this road is 1.8 kilometers. And trees were planted along both sides, meaning that trees were planted on this side A, then another set of trees were also planted on this other region. And they were put 20 meters apart. 20 meters apart. How many trees were planted all together? First, what you need to check here, there are two units here. We have kilometers and we have the meters. So the first thing that you should always do is convert these kilometers to meters so that they can be in same units. Convert the kilometers into meters so that they can be in same units. That is why I started by that story where children told me about Kenya has dug many dams containing minerals. And we know that 1 kilometer is equal to 1,000. 1 kilometer is equal to 1,000 meters. So we shall simply convert this 1.8 kilometers to meters. That would be 1.8 kilometers is the same as 18 over 10. 18 over 10, because of one decimal place here. 18 over 10, we multiply by 1,000. Multiply by 1,000 meters. So this one will cancel this. Multiply there. We shall find that this distance was 1,800 meters. Meaning that the distance on one side was 1,800 meters. The distance on this other side will also be 1,800 meters. So, to find the number of trees that were planted here, we shall simply come and apply the formula. We say that if it is a straight line, we take the distance, we divide by the intervals, we add to 1. And I always tell children to avoid wasting time in maths because I talked of speed and accuracy. We know that these lengths are 2, one side and the other side. So you simply get the total distance, that is 1,800 plus 1,800. But instead of adding 1, we shall add 2. Why are we adding 2? Because there will be one tree here, another post here. That is why we add 2. So get the total length for both sides. That is 1,800. This one 1,800, 1,800. So we multiply this by 2. We shall get 3,600. This is meters. We divide by the intervals. We are told that they are put 20 meters apart. We get 180 there, and I've said you add 2. So we take 180 plus 2. Our answer will be 182. 182 what? The question is, how many trees? 182 trees. I always tell children to put the units there because we may never know what you are talking about. The other long way of doing this, and I don't always encourage children to use the long way. The long way of doing this is finding the number of trees on one side here. That is 1,800. 1,800. We divide by 20. Here we shall get 90 plus 1. We get 91. That is for one side we get 91. And automatically if one side is 91, this other side is also 91. We add the 2, we shall get 182. We move on. I've said that if there's a question, use the WhatsApp handle that is given on the screen, the KUTV WhatsApp handle. Let us know your concerns. I'll answer them before the lesson ends. And let it be much related to the intervals and revolutions, because this is quite a wide topic. We move to the next bit. Sometimes now you are not asked about the number of posts, but now what is needed is the distance. You are already given, sometimes what is needed here is now the distance. You are already given, you are given the intervals, and you are given the number of posts. So the question would be, what was the distance? And we shall also start again with the distance for enclosed field. Enclosed. When it is enclosed, and I've said that a figure that is enclosed is like, it could be a rectangular one. It can take any shape. It can be triangular. It can be circular. So we want to get the formula of getting an enclosed one, the distance for an enclosed, and you are given number of posts. And the formula we are going to apply there will be number of items times intervals. Number of items, and when I mean what I mean by number of items, it could be the posts, it could be the flowers, whatever you are using, fixing at a distance, times intervals. Number of items times intervals. Let me give an example. 30 flower bushes, 30 flower bushes were planted around a circular fish pond. I know there are children who have never come across a fish pond. They just know the fish from the sea or the lake. At intervals of 3 meters apart. What is the circumference? What is the circumference of the fish pond? What is the circumference of the fish pond? One thing that I've always noted is that children never want to attempt questions that are having long sentences. And these questions are always very easy. Let us check with this one. Once you understand what is to be done, you'll get that the working will always be very easy. Look at this. 30 flower bushes were planted round a circular fish pond. Have the picture of that, whatever you are given, that a circular fish pond. Have that picture in mind. At intervals of 3 meters, that they were put 3 meters apart, 3 meters apart. What is the circumference of the fish pond? The question that will challenge most learners here is that when they find that what is the circumference, they know that this is now the end of me. They want circumference. What am I going to do here? Circumference. This is a very strange term. So circumference is simply total distance around a figure. Circumference is just distance around a figure. So in simple words, you are just being told, find the distance around this point. Find the distance around this one. And we've given that our formula is that to find the distance around enclosed one, we shall take number of items, or the posts that are used, times intervals. So go back to the question that there were 30 flower bushes. So 30 becomes the number of items. Take 30 times the intervals, 3 meters. So 30 times 3 is 90 meters. Dear learner, this is our answer. Somebody would have really thought hard and hard that what is this now? Circumference again. Fish pond circumference. How are they related? And the answer is very simple. Just take the number of items, multiply by intervals, and you get your answer, and you smile. Then you go out and tell the teacher, maths is very easy. Don't start shouting, maths is very easy. Then when the final results come out, then you start scratching. Oh, I almost got it. I missed one. Make it very easy. Maths is very easy. Let us make it very easy the way it should be. So we want to look at distance in an open field. To find distance in an open field. Like when you are given a straight line here, you already given a number of posts used and you are given intervals. What are you going to do to find your answer? And the formula is also very simple. Just take number of items minus 1 times intervals. Why are we subtracting 1? When you remember keenly, when I was introducing this lesson, I said that when we are getting number of items in an open field, we add 1 at the end of it because of that last post. Now we have to remove it because it is not catering for any distance. It doesn't cater for any distance. An example in a question would be 81 electric posts, 81 electric poles are fixed at equal intervals. 81 electric poles are fixed at equal intervals of 15 meters apart along a feeder road. A feeder road is not a main road. From the word feed, find the distance of the feeder road. Find the distance of the feeder road. Dear learner, when you come across such a sum in exam, just smile and say this is free marks. You only need to interpret what is given here. Take what is given to real life. You don't even need to think about the formula. Just try to draw whatever, the road. We don't know the length of that road, but we are told that poles are fixed at equal intervals of 15 meters apart at a feeder rod. Find the distance of the feeder rod. And there are 81 electric poles. There are 81. We don't know how long the distance is, but they are fixed at 15 meters apart. Go back to the formula. Say that the distance of an open field is equal to number of items minus 1. The number of items here is 81 minus 1 times the intervals. And the intervals here we are given is 15 meters apart. So this is board mass. Work out what is in the bracket first. That is 81 minus 1. We shall get 80 multiplied by 15. If you multiply 80 by 15, you get 1,200. As simple as that. 1,200. As simple as that. I can see your feedback. Still let them come. If you have a question, let them come. Let them come. I'll answer all of them. Let them come. I want to go to the very last part of that intervals and revolutions. Then of the intervals and the distances. Then I'll go to the revolution and we summarize so that I can handle your questions. Remember, maths is all about speed. It's all about accuracy. It's all about the formulae. Speed, accuracy, and formulae. So there is an example of a question here. And this is now the last part we are dealing with. I'll give you the formulas for intervals. We've talked about the distance. We've talked the number of items. And to find intervals, we shall say the interval is equal to distance over number of items. Distance over number of items. This is for closed region. This is for closed region. And to find intervals for an open region, an area that is not closed, we say it is distance over number of items. Number of items minus 1. Number of items minus 1. An example in a question, there's a question that is given here. There's a question that is given here. A circular fish pond. Circular fish pond of radius 42 meters was fenced using posts of 6 meters apart. If one post costs, if one post costs 235 shillings, find how much was spent on buying the posts used. That is our question. That a circular fish pond of radius 42 meters was fenced using posts 6 meters apart. If one post was 235, find how much was spent on buying the posts used. First, you come back to the formula. And we want to know the amount that was used here. And to get the amount used here, we have to first get how many posts were here. How many posts were used in this place? This is a KCP question, that a circular fish pond of radius 42 meters was fenced using posts 6 meters apart. If one post cost this one, find how much was spent altogether buying the posts used. So we have to find the total distance. We have to find the total distance first, then get the number of posts that were here. And how do we get the total distance around this circular fish pond? To find the distance, the total distance of a fish pond, this is the same as finding circumference. And we all know that circumference of a circle is equal to pi d. Circumference of a circle is equal to pi d. So simply apply the formula. Pi is always 22 over 7 times the diameter. What is the diameter here? We are given a radius of 42. And we know 2 radii gives us a diameter. So we take 42 times 2. 42 times 2 is 84. 84, there goes 1. Remainder 2. Remainder 1 into 14 twice. Take 22 times 12. That should be 264. Let's confirm. 22 times 12. Here is 4, 4, 2, 2. 264. So the total distance here was 264 meters. And they were fenced 5 meters apart. So we divide this one by 6 meters apart, by 6. We divide by 6. 6 goes here once. 6 goes into 26 how many times? 4 times. Good. Remainder 2. We get there 44. So we had 44 posts used here. There were 44 posts. That is not the question asked. This question was asking about money. We are told that one post is equal to 235. Therefore, 44 posts would be 235 times 44. 235 times 44. I want to make our work easier. I get my answer to be 10,340 shillings. So that is our answer there. We go to revolutions and circumference. We go to revolutions. And that will be the last part of this lesson. Revolution. We go to the revolutions. Revolution and circumference. Revolution and circumference. The word revolution comes from revolve, meaning to go round. These are also a very simple but tricky question that always challenge learners. They are given to work out the number of revolutions or distance or circumference. And I'll start by giving formula. Distance is equal to circumference. Circumference times revolutions. Dear learners, after knowing one formula, it is always enough to take you through the rest of the formula. You just need to know one. After knowing one, you'll be good to go. Like if you want to get the revolutions now from here, if you did fractions, and I saw the previous lesson was about fractions, like if you want to get the circumference now, you'll simply divide this side by revolution, and this side by over revolutions. So let us look at an example in a question. Let us look at an example in a question. An example in a question would be Rhoda rolled a ring of radius. Rhoda rolled a ring of radius 42 centimeters, which covered a distance of 396 decameter. How many revolutions did it make? How many revolutions did it make? And here again, we see we have two units that are contrasting. We have the decameter, we also have the centimeters. And when we were beginning, I told you that story of those learners. That is what is now helpful here. We shall need to convert this one first to centimeters. And we know that one decameter is equal to 1,000. Is equal to 1,000 centimeters. 1 decameter is equal to 1,000 centimeters. So first start by changing the units. This one. We shall take 396 times 1,000. We get 396,000 centimeters. So that one is the distance. And we are told that this thing had a radius of 42 centimeters. How many revolutions did it make? Come back to the formula. How do we get revolution? Revolution is equal to distance over circumference. You can substitute this side. You learn something in fractions called substitution. You substitute this side by circumference. So you will find that the formula for getting revolution is equal to distance over circumference. So we need to get the distance over circumference. The distance is already given here. So let us find the circumference of this circle. And we say that circumference is equal to pi d. Circumference is equal to pi d. Circumference is equal to pi d. 22 over 7 times the diameter. We say that the two radii makes a diameter. So this will be 42 times 2. 42 times 2 is 84. There ones, 12. And you remember what we did the other time. 22 times 12 is 200 and what? I know the class is not here. I'm forgetting that some children are here. 22 times 12 is 264. So the circumference here is 264. What do we do after getting the circumference? We take the formula now. We've said that circumference, the question here, the revolution. Revolution is equal to distance over circumference. So we take the distance, 396, divide by 264. Simplify this one. You can start from the simplest bit. Like we know that these numbers can be, they are all divisible by 2. So 2 goes here once, 3, 2. 2 here once, remainder 1, that is 9, remainder 1, 8. 2 can still go into these numbers. 2 goes here, 6, remainder 1, 6. 2 goes here, 9, 9. So we have 99000. We have 66. Another number that can simply divide these numbers is 11, because you can see that 11 can go into 99. 11 can go here. Simplify this one. Our final answer will be, I want to make your work easier, 1,500. 1,500 revolutions. 1,500 revolutions. So up to that point, I want to believe that I have been clear about how we go through revolutions. So I want us to check how to go through circumference. That will be the last bit. Then I'll go through these questions. I've seen there are very many questions coming in. I'll go through them. Get a question somewhere. If it is KCP, you can ask. If we have time, we shall find time to answer them. The last question would be, I'll give it number 5, that Terry Ann's bicycle wheel made 3,000 complete. The word complete there means full. It turned fully. 3,000 complete revolutions, covering a distance of 1.32 kilometers. What was the diameter? What was the diameter of the wheel in centimeters? What was the diameter of the wheel in centimeters? Again, once more, learners, you can see that there are 2 units that are given here, and we always have to make them same or similar. We have the centimeters here, we have the kilometers here. So the first thing we are going to do is to recall about our Kenya has dug many dams, and I told you that it is not good to cram maths. It is always good to know. Just know the formula that 1 kilometer is equal to 100,000 centimeters. 1 kilometer is equal to 100,000 centimeters. Therefore, we want to change this one. We want to know this distance first in centimeters. That is why we are starting by converting the units. Therefore, 1.32 kilometers would be equal to, multiply this one by 100,000. 1.32 is the same as 132 over 100 because of the 2 decimal places. Multiply by 100,000. Multiply by 100,000. Those zeros will cancel. We shall have 132 centimeters. And it is always good, learners, to organize your work properly, the way I'm doing mine on the board. I always don't like children doing some work at the back, then they tell you, teacher, this is the answer. It is very hard to know whether you copied or you actually did the work. So always show your calculation step by step. It is very, very important in maths. The question here is, what was the diameter? The diameter. When children think of diameter, they are already saying, okay, let me move to the next one. I see what is next. This sum is very easy, learners. What was the diameter? So meaning that to get the diameter, you should have at the back of your mind that the diameter is related to the circumference. Diameter is related to circumference. And how do we find circumference when dealing with revolutions? We put the formula that the circumference is equal to distance over revolutions. Distance over revolutions. The distance given here is 132,000 divided by the revolutions. The revolutions, the number of turns the wheel made, we divide by 3,000. What do we get? Simplify. That 0 will cancel. This one will cancel that. Then 3 goes here once. 3 cannot go into 1. It goes into 12 4 times. Remainder 1. We put that one closer there. Then we say that 3 goes into 12 how many times? 4 times. So meaning that circumference here is 44. Wow. That circumference becomes 44. And they are centimeters. Remember, learners, that this is not the question asked. The question asked is, what is the diameter of the wheel? We've really worked out. We started with changing this one to centimeters. We found the circumference. Then have at the back of your mind that circumference is equal to pi d, circumference of a circle, because we are told that Terrian's bicycle wheel, a bicycle wheel must be circular. A bicycle wheel must be circular. This Terrian's bicycle made, meaning that we found that this wheel has a circumference of 44. To get the diameter from there, we apply the formula the way I've said, right? Circumference is equal to pi d. And what is that circumference here? Dear learners, circumference, we are already given there to be 44. So we say 44 is equal to pi d. 44 is equal to 22. Pi we know is 22 over 7 times d, pi d. So what do we do to get d this side alone? To get d this side alone, we multiply both sides by the reciprocal. We take 44 is equal to 22 over 7 times d, and the reciprocal of this number is 7 over 22. We multiply both sides by 7 over 22. This one cancel that one, this one cancel that one, meaning that other side, this other side will remain with d. Simplify this side. 1, 2. We take 2 times 7. That is 14. You go back to the question. What was the diameter of the wheel? Then you smile. I've found it. The diameter of the wheel is 14. Write your answer and move on to the next question. I believe learners have made your work a bit simpler. Let me go through the questions that are given here. I can see very many people are watching. David Odongo is following from Oma Bay. Manasseh, thank you for a great introduction. I can see Felix Owor, Mama Stephanie, okay, I can see. Good morning, teacher. I'm Eve. Could you please repeat that formula of conversion of kilometers, centimeters, and others? Thank you, Eve. And this one is, Eve, what you need to know here is, I always tell children that you just need to know it. The method that you are using for knowing it doesn't matter. What you need to know is you know it. That is what counts. So my learners, I told you that my learners, when I entered that class one day, they told me, teacher, I wrote measurements, then they, Kenya has dug many dams containing minerals. How is this related to maths? So, if this is the formula, just take those initials. Kenya has dug many dams containing minerals. So this is kilometer, hectometer, this is decameter, this is meter, this is decimeter, this is centimeter, this is meter. You start relating them this way, that 1 kilometer is equal to 10 of this one. 1 kilometer is equal to 100 of this one. 1 kilometer is equal to 1,000 meters. 1 kilometer, so what you need to write here are the zeros. Write the zeros. Write the zeros. This one will help you a lot. Like when you want to compare a centimeter with a kilometer, you will say 1 kilometer is equal to, you write 1 there. 1 kilometer is equal to 100,000 centimeters. 1 decameter is equal to, the zeros from here to here should be just 1. If it is a gap of 1, it is just 1 0. 1 hectometer is equal to 10 decameters. 1 decameter is equal to 10 meters. When you skip 2, 1 decameter is equal to 100. Here will be 2 zeros. Is equal to 100 decimeters. And hello teacher, I'm Ernest watching from Kakamega. Why do you add 2 to 180? Ernest, if I recall the sum, it was about 2 lines this way. It was 2 lines, and we worked out, we were told that, we found out that for 1 line was 90, and we added 1 here. Then for another line is 90, we added 1 here. So what I did in my calculation, I put this one together. Like I had the 190 plus 90, then 2 plus 2. That is why I was saying that maths is all about speed. So what was in my mind was about speed. But you can work out one side, getting the number of posts to one side. Like maybe you find the posts that are here were 90. Then you add 1 because of this last one. There is that post that is put at the last. That doesn't cater for any distance. That is in an open field. So this is 90. You also work out the other length. You find 91. But there is no, you should not take that pain of taking long doing a sum that way. Make it simple. Make it simple. Hello teacher, I'm Crispin from Ambira. Here is the question. To fence one side of his farm, a farmer requires 25 posts placed 24 meters apart. How many posts will he require if the posts were 24 meters? How many posts will he require when the Crispin, this is just a matter of language, that a farmer requires 24. This is now not even in intervals and revolutions. This goes back to direct and indirect proportions. This goes back to direct and indirect proportions. Like when he requires 24 posts placed 4 meters apart, how many will he require if they were placed 3 meters apart? If they are 25 and they were placed 4 meters apart, now when they are put 3 meters apart, are they going to be more or less? They are going to be more. So that is direct and indirect proportion. You can have one side post. You can have these sides, the meters. We are told that they are 25, 4 meters. When they are 3, put at 3 meters, at what distance will it be? That is indirect proportion. Simply cancel and find the number of posts. The next question, George from Mombasa, Shanzu, thank you for seamless flow of topic. My students are good to go. They are watching KUTV. Thanks a lot, Mwalimu George. I'm Lydia from Nakuru, and I need you to tackle this question. Onyango set aside a square piece of land. We shall check in the interest of time. If time will not allow us, I'll just give you the tips on how to go about it. A square piece of land with an area, the area here. How many grass on the piece of land were, he planted grass on the piece of land leaving a path of 3 meters all the way round. What is the area covered by the grass? You know, this is a question that is dealing with now area. And you remember the topic we were covering today was simply about the intervals and the post being placed at one point. This is a question that is dealing with area, and it is quite a wide topic. First, what you need to go back and find, what is the length of one side? This is a square piece of land. Get the square root of this one. After getting the square root of that one, you'll find that one side will be the length of what? Another side will be what length? Then compare with the spaces that were put here. You will get your answer right. Good morning, teacher. I appreciate you a lot. I've learned a lot. Thank you. Eled Queen from Kisumu. 30, yes? These will be the last questions. Eled Queen from Kisumu, 33 post. I just want to give you tips on how to go about them. Eled Queen from Kisumu, 33 posts. There are 33 posts. Were placed in a row. At intervals of 2 meters. 2 meters apart. A pupil ran from the first post to the last one and back. This is all about the distance. What distance did he cover? You know, and this question is very challenging in a way that you may be tricked to find that you are looking for both sides. You know, when somebody is running, he is simply taking one route. He's simply taking one route. He's simply going towards one direction. So there is, what you need to know here is find the post. I see many questions are coming. They were placed 2 meters apart. So remove this one from that one, that is one last post. It will be a distance of 32. Is it meters or kilometers? It will be a distance of 32. There will be 32 posts. 32 posts placed in a row of 2 meters apart. Multiply this by 2. I've subtracted 1 there. You remember our formula of subtracting 1? After take 32, you multiply by 2, you'll get 64. And it is meters. That brings us to the end of the questions. Remind you that if you have a question, next time use the WhatsApp handle that is given by the KUTV. I can see a lot of my pupils followed me through my WhatsApp. Thank you very much. I believe when God allows, we shall handle the next topic that is related to this revolution. There is that question that was asking about centimeters that are put. It is a wide topic that needs extra time. I could not just handle it within the few minutes that we have. Once more, I want to remind you that when schooling stops, learning should continue. Get every opportunity to learn, and KUTV is the place to be. Thank you very much. May God bless you till another time.